Please open for Actionable Insight from Cyberthreat and Vulnerable Data folder. Then open up the Actionable Insight from Cyberthreat and Vulnerable Data PowerPoint. The material introduces tactics and techniques used by attackers and methods which can be used to classify low-level attack traces. After setting up your environment with Slides 2 Environment Setup PowerPoints, please open up the lab folder. So we're going to go back to our folder, go to Labs, and we're going to open up the homework document file to access the exercises. So it should look like this, and here are your questions that you will need to answer. Now, question 1 requires you to build an SVM classifier to complete the exercise. Open the needed files folder. So we're going to open up needs folder, and we're going to open up the classify Python file. The file contains the code, and you're required to complete the code. So here we're going to import the NumPy module for array manipulation. And then here we're going to import the ARFF module for load data in ARFF format. And as we go further down, we're also going to import the sys module for reading input from command line. Here we declare the variable for splitting the data to training and testing set. And then we declare the function for load data from ARFF files. It takes the ARFF files as input and returns the data instances and the labels. At line 24, it declares the line for reading data from the file specified at the command line. And from here to here, it is used to find the best parameter for the SVM model. At this line, it initializes the SVM model with the parameters learned from the parameter search. Here, it is used to split the data to training and testing data. So for question 1, please run the code to verify the SVM code is initialized. After initializing your SVM model, please train your model with your dataset. First, use the data packet.arff. For this exercise, the training data set is already generated and stored in variable xtrain in the labels as ytrain in line 47. Please use this data to train your SVM model. Using data's syscall.arff, build an SVM model as described in question 1.2. After training your model, please use your model to predict the labels for your test data. With the results of your test labels, calculate the accuracy of your classifier model. The true labels are stored in variable y_test. You can calculate the accuracy by using the following formula. Number of correctly labeled divided by the total number of test instances. Using data syscall.arff, please obtain the classifier accuracy. Please compare the accuracy of your classifier when using packet level data versus the syscall level data. You can vary the split ratio between training and test data by modifying the split ratio values in line 10. To complete this exercise, set the ratio module to 0.1, 0.2, 0.3, 0.4, and 0.5. For each individual split ratio, calculate the classifier accuracy. So as for the solution, we're going to go into the folder and we're going to open up classify solutions Python file. Okay, so for question 1, Using the data underscore packet.arff as the argument to classify solutions Python, run the Python file. So let's go ahead and open up our terminal. And okay, and your output should look something like this. So for line 38, it initializes the SVM model. And for question 1.2 and question 1.3, rerun the file with data underscore syscall.arff as input argument. To train the SVM classifier, line 49 is used to fit the SVM model with the X underscore train and Y underscore train data. As for question 2, line 50 predicts the labels of the test data. For question 2.2a, here at this line compares the predicted values against the actual values as shown in this line right here. Using data underscore packet.arff as input data, the accuracy is calculated at this line right here. For question 2.2b, similarly using data underscore syscall.arff, the accuracy is calculated in line 62. And for question 2.3, by modifying line 10, we can vary the split ratio and obtain the classifier accuracy.